Welcome everyone to today's xTalk. I'm really excited to have you all here. So my name is Jovi Nazarino. I'm the Learning Science and Education Outreach Specialist on the Open Learning Residential Education team. I'll go into the actual thing we're here for, which is today's talk on generative AI and teaching at MIT. So this is actually kicking off our fall AI and teaching series that is co-sponsored by Open Learning and the Teaching and Learning Lab. So this is the first of a couple of events coming up. So today we are lucky to have two special speakers today, or two panelists. First we have Per Urlaub, who's going to present first. He is a professor of practice in German and second language studies, as well as the director of global languages. And we also have Michael Strano, who is the Carbon P-Dubs professor of chemical engineering, also the founder and lead principal investigator for the Center for Enhanced Nanofluid Transport, as well as for Disruptive and Sustainable Technology for Agricultural Precision. So they are both here to talk about how they are actually using generative AI in their subjects here at MIT. So we'll welcome them up and we'll go ahead and get started.
Hello everybody, it's very nice to be here and to see so many familiar faces. Thank you so much for the invitation, for organizing everything. I have gotten the very difficult task from you to talk about things that are very near and dear to my heart within 10 to 15 minutes. I will do my very best to stay within that time limitation. I will keep my examples relatively broad because I have the urge to talk also about some of the theoretical frameworks that guide me and maybe some of my colleagues in incorporating AI in language education and the humanities, with the hope that this is something that you can take back into your various disciplines as you start and continue and refine your reflections on how to deal with AI in the classroom. So before I talk about how, I actually want to talk about why. Why do I think it's important to consider the incorporation of AI in language and humanities classrooms? When we hear AI, we of course intuitively, primarily, first, instinctively think about STEM education. But I think it is incredibly important to consider AI throughout the entire academic spectrum that this institution offers. This is arguably the defining technological breakthrough of a generation, of a decade, maybe of the century, at least so far, and has a profound impact on how humans innovate, how humans communicate, how humans think, and even how we feel. Human-centric perspectives provided by the humanities need to be considered as we continue to grapple with these questions that relate to the benefits and the risks of AI. So in our classes at MIT, all of us, I feel, must give students opportunities to critically reflect on the affordances and limitations of generative AI. This will help future generations of innovators to further develop AI in responsible ways and in ethical ways. Long story short, AI literacy matters and must be, in my view, at the forefront of all fields at MIT and not just in STEM education. AI also has the potential to be an amazing instructional technology. And this is what I will talk today primarily. So before giving you a few examples, I want to briefly talk about the pedagogical framework that many of you may be familiar with, that I use when I'm thinking and when I'm designing activities and tasks for students that provide them with opportunities to collaborate with AI. My collaborator, my human collaborator, I should say, not my AI collaborator, Eva Dessein, who is at MIT here in French, and I have written more about this in greater detail, what you're about to hear, and you can, if you're interested, access publications from my academia.edu website. But let me start with Soviet child psychology of the early 20th century. The Russian child psychologist Lev Vygotsky has developed in the 1920s, 1930s Soviet Union a theory that is surprisingly relevant to us today as we design AI-enhanced learning environments. The zone of proximate development suggests that all human development and learning is based on social interaction. Essentially, there are three kinds of scenario. Either a learner is confronted with a task that they cannot complete or tackle independently, unassisted. Or a learner or human is confronted with a task that they effortlessly can complete all by themselves. There's a third scenario, and that's the task that the human cannot complete unassisted, but he or she is able to accomplish it through interaction with an expert. This sounds now a little bit abstract, but I will give you an example that Vygotsky used in order to illustrate this zone of proximate development through the motoric development of the child. Either the child cannot walk as a baby, yeah? Or as a toddler, it can walk. But there is a critical phase, which is the zone of proximate development, and that is the parent supporting the child through a lot of trial and error in growing into the being that then can walk independently. So there's the baby that lies on the floor, so to say, not be able to walk. There's the toddler that's perfectly able to walk. But then there is the zone of proximate development, which is the interaction between an expert system, the parent in that context, and the learner, the child in that context, that can walk, sort of wobbly, I guess, assisted by the expert. And this is exactly the metaphor that I think about how one can use AI in language and humanities education classes in a really, really interesting way to provide students with interactive guidance so that they grow linguistically and intellectually in their writing, in their thinking, and in all domains that are relevant for our teaching in the humanities. So this zone of proximate development is something where I look for opportunities. How can this technology be deployed in a way that students interact in ways that they grow linguistically, that they grow intellectually through these interactions with the technology? So I will give you three very, very, very rough examples. I teach a course, I started teaching this course the first semester I taught here in fall 2022. And I had started working on machine translation a couple of years, couple of years before the pandemic. I found it very, very unsatisfactory that the default response to machine translation and Google Translate and the vast improvements that Google Translate has made in recent years, exactly when they moved from a rule-based system to a machine learning system, that has met by my professional community, language educators across the country, basically with a way like, let's ban that stuff. Yeah? Let's put it on the syllabi, don't use Google Translate. And I've been guilty of that myself. 10 years ago, 15 years ago, it was very easy to convince students because you could just demonstrate how bad these systems were. Now they're frighteningly good. Anyways, so I've gotten more interested in machine translation, and translation is a lifelong passion. And as somebody who was originally trained as a literary scholar, it's of course literary translation that I consider to this day as the pinnacle of the art and the craft of translation. So I taught a class called Lost in Translation, Word Literature in the Age of AI. It's a class that's taught in English, where students not only discuss translation theories from antiquity to postmodernity, that centered on this central concern of the art of translation. Should a translator focus on accuracy of the level of the word, or should they focus on the overall sense of a passage? My students also translated expository and literary texts from languages of their own choice into English and wrote reflections on their translatory decisions that relate to this tension between translating word by word or translating sense to sense. Then they compared their translation with the output of Google Translate or LLMs that are prompted to translate passages. And this provided them with an opportunity to critically reflect on the translatory decisions that these algorithms make for us. Next class. In my advanced German language classes, generation of students, I have to say by now, because there are really generations of students, have refined communicative skills through role plays. But I've been in the last couple of years gotten increasingly unhappy with the difficulties for students to prepare for role plays before class. Last semester was different. My students used a prompt that was originally engineered by my wonderful colleague here at MIT in Japanese, Takako Aikawa, for her Japanese students. The prompt provides students with the opportunity to engage in a simulated job interview in the target language, interacting with a chatbot. They use the prompt at home to prepare for the class. And even though the interaction was in typing, they found it very useful. And the fact that now it is even available through speech will make this task even more meaningful, I hope, for them in the future. But there you can see traces of my Vygotskian thinking. Yeah? The AI is there in order to provide the students with an interactive opportunity to grow a skill set. And lastly, I want to talk about my class that I'm teaching this semester. So this is all perhaps a little bit more aspirational than something that already happened. It's a class I also teach in English for students to develop a critical understanding of the European integration that occurred in the second half of the 20th century, but as well also for anti-European and Europe-skeptic populist, nationalist movements that we see popping up in the last 15 years all over Europe in this 21st century. It's a class that's very, 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 as a European and as a German, a class that's very, very, very near and dear to me, to give this generation the opportunity, on the one hand, appreciate the fact that a continent that has been absolutely shattered by war and the worst crimes in the history of humanity has miraculously, seemingly miraculously, gotten their act together, and in the 20th century, second half of the 20th century, created this harmonious, prosperous space. Yeah. But also, I mean, I think that gives hope for students today to understand that something like that is possible. But it's also important for students to realize how fragile this construct is if you see what's going on today in Europe. This is a writing-intensive class, and students write throughout the semester, but there's also a substantial paper in the end of the term. And that's, of course, the dreaded situation where a lot of humanities professors feel, oh my God, will they cheat? Yeah? Students are actually not permitted to use AI until they have completed and submitted the first version of this paper completely without the help of any AI tools. I have to trust them. I trust my students. Maybe it's naive, but I do. After receiving feedback from me, they have the option to then use prompts that I provide them with, to guide them also, that help them to refine their writing. So these prompts, and this is very important, will not rewrite the paper or paragraphs in the paper. These prompts will instead help them to identify weaknesses in their writing and list editorial suggestions that the students then can choose to incorporate or not incorporate into the final submission. In other ways, AI is taking the role of a writing tutor. Probably not as good as a really good writing tutor. But I've been actually quite surprised how well LLMs can provide this kind of feedback. Not just like, oh yeah, just like give me an improved version of this paper or of this paragraph, but just like help me to identify where are some of my weaknesses as writing and make editorial suggestions that I can use in order to improve. Yeah? So that then engages the learner to actively go back into the paper with a list of suggestions that he or she gets from AI. I started to try some of that last spring in an advanced German course, the same course that where we used the chatbot interview. There it's even more obviously possible because you can ask, you write even as an advanced learner of German. For those of you who have learned German, you know that something like adjective endings are really difficult to, even as a high intermediate or low advanced learner, to have full control over. Yeah? So there is always a lot of space for an LLM to correct you. But you don't want to be corrected by the LLM simply by being given the correct answer. You want that the LLM is highlighting you mistakes, and then you can start thinking, and then in the next step, the LLM can give you rules, and you can start applying them so that you grow as an independent user of the language, and eventually the technology is not something that is our greatest fear as educators, that students use the technology in ways that it will sabotage their learning, but that it enhances the learning. So in my classes, students are not allowed to use AI to delegate tedious but necessary tasks to the technology and blindly accept the output. Instead, I do the contrary. I design opportunities that will allow my students to reflect critically as they grow linguistically and intellectually through an engagement in human-machine collaboration. Thank you.
I think my colleague did an excellent job of framing the problem, but I'm going to give you an example from a different domain. I'm an engineer, and I teach an engineering course here at the Institute. How many engineers are in the audience now? So we have a few. Okay, all right. So I've abstracted my talk, and I've removed a lot of data and content. The title is Large Language Models and Chemical Engineering Graduate Education. It sounds lofty, but actually it's a very modest educational experiment that I've ran in a graduate course that I've taught for about 10 years. And I'll explain why I did it. And it had mixed results, but I think there's things for people in this room to learn about. Okay, so the course that I teach, I'll just give it to you as a glance. It's a graduate level engineering course. It's required of our first year graduate students. It's a fairly mathematically intensive and programming intensive class. How many of you have ever written a program, a computer program? You have? Okay. Oh, good. Excellent. Good. If you're here, so it's a graduate requirement. It has about 50 to 70 students. It's taught in the spring, and in addition to 2 midterms and a final, there's weekly homework assignments. which I've tried to calibrate and maximize their learning. They're the focus of this educational experiment. Okay, so I'll give you my particular goals. I'll try to abstract these. So to do the most interesting problems, this is a chemical reaction engineering course. A chemical reactor, broadly, this is what chemical engineers study. A reactor can be thought of as anywhere there's chemistry and the movement of molecules. And that can be a battery in your car, that can be the earth or the atmosphere, or it can be chemical plants or power plants. It's really a skill set. But to solve the most interesting problems in this space, we actually need our students to write computer code, and a lot of you have done that. The issue I'm addressing, where I think AI can help address the problem, is the students already take a course focused on computer programming and engineering. We call it 1034. And they come into the class feeling they've already been credentialed on this. So why do I have to write more extensive code? And so there's always a balance between, if I say what a toy problem is, like a toy mathematical problem, is an abstracted one, very simple, easy to solve, but maybe doesn't have the detail that we want the students to. You can go all the way over to a very realistic problem. Lots of learning potential there, but you reach the students' frustration level, and they take it out on you in your learning, in your reviews. So the goal is, can AI make complex programming faster and easier, allowing for more effort placed on conceptual learning? And this can also make the course more inclusive, because students who don't know the programming language can potentially take it. They don't have to have studied the language. How many here have used Microsoft Copilot? Are you familiar with it? I'll use Copilot and ChatGPT, and I think it uses the engine. I'll use those interchangeably. I don't want to be confusing. So this is the Copilot interface. And to give you an example, how many have used an AI program like this to write code? How many? We have a lot of programmers. You used it to write code. So you know that you can put a prompt in just regular words. I'm sorry about the math for those of you who are not math focused. But this is the wording of a problem that a student might encounter in a mathematics textbook. Exactly how they would describe it. Like, I want the computer to do this. This is exactly what a student would tell you. I know it seems like gobbledygook, but engineers actually would frame a problem in this way. Well, if you put this into Copilot and you ask it to write MATLAB code, that's very particular code, it can spit out, it can turn this one sentence into 13 lines of code that's perfectly accurate. And that actually saves students a lot of time. Imagine a homework assignment where a student has to do maybe a paragraph of things like this, producing a 100-line program. That's just one solution to one problem. In other words, we can potentially ask more detailed questions and not reach the student frustration level. Why am I programming again? So that was the goal. All right. Hopefully I'm not burying you in the technical details. Most of the class started aware of the tool, but using it rarely. And that's actually where we did actually move the needle. I have some details on the homework assignments and what we put inside, and I wonder if I can go through those just to give you some examples. Hopefully they're not too abstract. In the first assignment, it's a detailed problem, but one part we showed the students that they could cut and paste a mathematical equation. And Copilot could then relay all of the background information on this problem, show them how to solve it, remind them of their undergraduate training, and write code for them to solve it. So it's saving them time. They would normally look in a textbook, and it would take them time to do all this. It all comes back. So we're showing them that the tool can save them time. They can access a lot of their undergraduate knowledge very quickly, and that can also reduce frustration. This was largely a success. The next homework problem dealt with molecules. And this actually is where there is a shortcoming. The students were trying to calculate something related to molecules the way their geometry is, something called their collision radii. I have some abstractions of a molecule there. Copilot knows nothing about chemistry. It's completely ignorant. I'm sure that's a problem that can be fixed, but it reached the students' frustration level. When we encountered this, we actually wanted to show the students the limits of the tool. And I'll give you an example. You can go to Copilot now. You can ask it to draw the structure of aspirin. Aspirin, we've all taken aspirin. And it spits out this. And this is not a molecule. This is actually, it's gibberish. So it's the equivalent of asking it to draw a diagram of Europe, and it gives you like a crater on the moon. It's not even close. And the problem with that, but this is fixable. This will fix over time. I'm just giving you a snapshot of what you can use it for and whatnot. I think it was important to show the students this. Unfortunately, if a tool is not reliable, students are less likely to go to it. So in this case, anyone can see this is nonsense. But what if you really need an answer and you don't know that it's nonsense? So this is where I think we can do a better job. I don't want to go through all of these because I think we want to go through the panel, but I can describe some other things. Homework 3 asked to calculate the moment of inertia of a molecule. It's something engineers know how to do. If you ask ChatGPT to do it or Copilot to do it, it gives you an answer that's wrong, but it doesn't look wrong. And this highlights that if you give an ambiguous problem to this interface, it will give you an answer. That's a strength and a weakness. And in this case, you needed to give it a little more specificity in order to get the right answer. So it was good for students to see that. It's a little bit of an example of how they can engineer prompts. Homework 5 was where they really had to write a program using Copilot to actually write the code. It was largely a failure, but I'm not discouraged. For this problem, to save time, I normally give skeleton code, if that means anything, sort of like a template, and they fill it in. And I always think it's very grade school-like. It's not like I've taken a working program and I've taken stuff out of it, and I want them to put it back in, and I just don't think it has the same learning. I would rather them learn how to write their own code, but not reach that frustration level. So, but there's more to do there. The others were similar. We don't have to go through them. I did a survey afterwards. The project increased the usage of the tool for more than half the class. So I do consider it a success, despite the limitations that I saw. They're using the tool now more for other classes as well. So I think it had some value. Hopefully I'm not going through this too quickly. I think that, like we anticipated, most of the tools they were helpful mostly for coding, and that's what we targeted. But actually, connecting to pairs presentation, proofreading, and actually formatting text of their assignments, we saw a lot of use of that. Generating ideas. I mean, we're seeing the use of the tool far beyond just writing code. So I am encouraged by that. Number one negative reason, and I think this is good for us to learn, it's a snapshot in time. Students said repeatedly it did not give accurate answers. And so it doesn't give the answer correctly. We heard that over and over again. And I think for engineers, it's very unsettling to go to a tool and have to question whether it's giving you the right answer or not, or to have to fix its answer. Now, that is not an indictment of the tool. It's a snapshot in time. It's going to get better, and I have some suggestions. And this space is moving so quickly, I think my project is probably already obsolete, because I think there are newer tools that are coming out. Overall, when we said to rate their experience, it's mixed. It's what you would think, right? It's a mix. There were some benefits and there were some detriments, and students came away with a mix. You can see here where the tool worked, students were rated highly. Some did come across with a negative experience. It was really the fault of the tool, but I think it can be improved, and I can make these available to anyone who wants to. We have extensive survey data. I'm just trying to summarize it here. We asked them what they think we could do better. I'm going to continue doing things like this for my classes, trying to incorporate them. I think we heard repeatedly prompt engineering is, and so if we can teach them how to do prompt engineering, but from my perspective, maybe the tool could also become more accurate. More exercises in recitation. So the students were very thoughtful in how it could be improved. So lastly, yeah, so just as a summary, I think, although it had mixed results, the project was a success overall. Students were exposed and they experienced new AI features. I know that some of them were exposed to features they didn't know that the tool could use. They indicated that they're more likely than not to use these tools in the future. I want to highlight my department. My department head, Chris Prather, was fantastic. She did provide resources to help me with that. So that is a message, is that faculty, I think, on their own are strapped for time, and they're not really able to cram additional aspects like this into this particular course. Is a large required course, and it is difficult. I'm told that there's a list of faculty in my department that are very reluctant to teach this course. I'm sure everyone knows. Some improvements, yeah, to tutorials on construction to get the desired answers. I may actually move examples into lecture, actually, and I'm sure Per is doing that in his class. Copilot can need to be improved. It needs to be able to produce accurate code. I didn't show that, but some of the code that it produces is wrong, and it takes students more time. It has to become more chemically literate for chemical engineers to use it. So that's it. Yeah. Happy to take questions, or we can move to the panel. Yeah. Thanks a lot.
All right, well, I'll just start by saying thank you again for both of your presentations, because it was really great to hear the different kinds of use cases and also the thought behind ways to improve both the tools but also the experience for the students, right? It's very interesting to hear about. I'm sure folks have questions, but I will kick off with one, and then you folks can all ask questions. So one thing I was curious about, and I think you had a slide on this, Michael, do you have a sense for what students' experiences with the tool coming into the class and how much they have or haven't or been scared or not scared to use these tools already?
I can go first. I think the answer to that question depends on whether you're talking about undergraduates or graduates. My impression, just in interacting with the students, the undergraduates are a bit savvier for this. This tool has been around for more of their early education. The graduate students, I was surprised. They described its use. They described its use rarely. That's what I showed, and but they were knowledgeable of the tool. But they described its use in their coursework rarely, right? But I think you would get another answer for the undergraduates.
Interesting. Did you have anything you want to add?
Yeah, I mean, I'm teaching exclusively undergraduate students, and I think there is perhaps there's almost like a generational, even like a few years apart in terms of the kind of technological ecology in which people grow up. Yeah, when I was in grad school, something like Wikipedia was just like that was a dirty word. Yeah, so I hope very much that the people who were only a few years after me in grad school looked at it the way we look at it now, as like a really, really, really fantastic resource. But it's not the Encyclopedia Britannica. AI, generative AI, is not Google. Yeah, so I think there is really, or not a search engine. But in some ways, when I, in 1998, relatively late, had my first internet-connected computer and was sitting in front of a search engine and was supposed to type something in it, I probably felt very much like how I felt in December 2022, and just like, oops, there's something new. Let's try it out. How do I do that? Yeah. And I think it's really interesting to see how the younger generation who grows up with it uses it more frequently. The one thing that I'm concerned about, how critically it's used. Yeah? And I think that's very, very much resonating also with what you say. Yeah, there are huge problems in terms of accuracy. Yes, we will see improvements, but in many ways, knowledge has always to be integrated in a critical way. Yeah? If it's in a printed book, or if it's on some website, or if it's something produced by an LLM. And that's for me very, very important in terms of thinking about AI in undergraduate education, is to constantly infuse that ethos that the knowledge that comes out of these algorithms is there to be critically integrated and not there to be just like uncritically consumed. Yeah, so I engineer them like a non-engineer, so to say. Yeah, I've done a fair bit of learning from YouTube tutorials from people who are like half my age and have a third of the educational accomplishments that I have. A great deal on how people use LLMs. Yeah? And some of them are relatively simple, that you're all familiar with that. That one of the best way to start like a ChatGPT Copilot session is to give the LLM a role. Yeah? So that you basically say, you are my writing tutor, or you are conducting a job interview with me. And then you add more context. And so I build prompts that work for these very contexts that I introduce. But I'm also very strongly encouraging my students to think critically also about the prompts that I engineer. And my students always have better ideas than I do, which makes me incredibly happy, and help us as a group together to refine some of the prompts. Yeah? So I give them I give them a prompt to model, not necessarily line by line or word by word how to engineer a prompt, but how to strive to develop prompts that do exactly what I want their interactions with ChatGPT look like. I'm actually very, very transparent about this framework that I use with my students. I'm telling them, oh, we use AI not just because it's fun or because it's engaged or everybody has to do it, which happens a lot when I think educators get in touch with a new technology. But I'm very, very transparent about what kind of interactions I want them to have with the technology, and I'm absolutely delighted by the ways how not only quickly students get that I don't want them to use the technology just to delegate tedious but necessary tasks, but that I want them to use the technology in a way that they can grow. And then they look at the prompts, and then they're MIT students, so they have a lot of good suggestions.
Do you want to go first, Peter?
Oh yeah, good, yes. Well, one of the things is that in the context where I want my students to engage with AI as sort of a quote-unquote writing tutor, I always have them to not only submit a paper that they consider like an improved paper as a result of this interaction, not as a result of proofreading, but as a result of this tutor simulation. But I also require them with almost every task and every assignment that incorporates AI, they have to write a short critical reflection on how they feel the AI enhanced their learning in this context, but also what the limitations are. Yeah. So first of all, I find that fascinating and very, very, very interesting, and I get a lot of ideas from that. But more importantly, I want them to be critically engaged with the use of AI. I also very early in the semester make them aware of hallucinations, so to say. Yeah, when an LLM makes things up. One of the things that in my neck of the woods would be a great example would be, oh, give me 5 articles that I can quote in my paper on this and this matter in Europe, and it gives you 5 references. And 4 of these papers exist. You can go to Hayden Library or you can go to the internet and find the paper. And then the fifth paper is a completely made up, plausible title where you say, oh, that's a great paper. Yeah? Somebody should write it. But nobody has ever written it. Yeah? The second thing is that, and that's also connecting to Michael's survey, I am very, very, very blunt about telling them not to use AI in order to generate ideas. Yeah? Give me 5 topics for a paper on Shakespeare and Hamlet and gender issues. Yeah? So, and then ChatGPT gives you 5 wonderful papers, titles or topics for your paper to write. But I tell them, if you do that, it's not that AI is working for you, then you are working for AI, because AI tells you what to do, and you sit behind your computer and do that. Yeah? And don't do that. Don't work for AI. Have AI work for you in a productive way so that you can grow.
I'll just add, actually, I agree. Your question is critically important. And actually, I think we've reached the limit of what a tool can do. I think that has to be taught in a different way. And actually, in my course, in this very course, the students know that on their exams, my favorite is to put mistakes in textbooks or mistakes in the literature, even from prestigious people. There's almost, I think that's the way that you teach students to look critically at information. It's not correct just because it's in a textbook. I don't think the tool, so that's why we constructed this project. When AI fell short, we actually put that as part of the exercise. So you actually saw the limitations of the tool. And I think that's the only way to do that. I don't think there is a way. I think we need more of that. Engineers calculate things. We also teach them how to do orders of magnitude, how to check their calculation. Does it make sense? So I'm not really sure that there's a role for AI there. I think it's the target of our skepticism. Yeah. Well, I was going to say, it's a great example, and I should have highlighted that. The instructors for the class that comes before it that teaches programming, I think, I hope I'm framing their view on this now. One of them is a leader in this space. But I think they're taking the view more of restricting the use of the tool until you know the basics of how to program and the basics of mathematics. I think they don't want you, if I have this right, I think their view is to limit the use of the tool for in the way that I've outlined. I think until you get the basics, but I might be framing that too simplistically. Well, I personally, in my own research, I write a lot of code to help my students. I have started using Copilot. It's definitely going to be the future. It's hands down a very effective tool to help with programming. It's only going to get more and more accurate. I actually think I can foresee in a few years there may be a universal programming language. This would really benefit the students. Instead of having to learn all of these different packages, Python, Julia, MATLAB, Mathematica, I actually think students will be able to write just pseudocode. And maybe the AI will figure out the best package that has the attributes. I think this will be an enormous boost, not just to the field, not just educationally, but I think just a tool. It'll open up engineering to a greater portion of the population. Like we don't want our students in engineering to become computer scientists just for the sake of it. We have to teach them computation because that's the way you solve the most relevant problems, right? We taught them how to use a slide rule too, right? Because that's what you needed to do. Does anybody know what a slide rule is? Okay, yeah, so we don't teach that anymore. So we don't necessarily want students to learn data structures and how to make, it's just a means to an end. And I see good things actually on that.
I think the question is really a great one. And it reminds me really to a discussion, and I'm now talking outside the humanities and languages, but in math education and the invention or proliferation of the pocket calculator. And it took 20 years for math educators at the K-12 level to figure out when is the ideal time to introduce the pocket calculator, and people still haven't agreed on it. Yeah? So I think there is I think it's an important discussion to have that. Also, if you think about like what the classes that students take before and how it impacts their motivation or how it impacts their work in other classes and how it will impact them in the future, like so having a curricular view on it besides having the class, looking at it at the class. But I think it's a very, very, very important question, but it's a very difficult question. For me, it's I constantly when I give talks in front of language educators, people ask me, well, how much do students have to learn to use the language independently before we can allow them to use machine translation or AI in order to enhance their linguistic abilities? And I always say it completely depends on your context. Yeah? So, and it depends in the end of the day on what you want the educational outcomes to be of your curriculum. Yeah? So that is, and that happened in math education. It's really a backwashing process. The watershed moment for the pocket calculator was really only in, I think, 1994, when the SAT College Board allowed students to use pocket calculators in college entry exams. Yeah? And that was then basically the last nail in the coffin of the slide ruler, and made the pocket calculator an less controversial tool in our schools. But it also inspired math educators to rethink the objectives of math education from an accuracy-driven, I'm talking about math now, which is a joke, an accuracy-driven skill towards something that goes more conceptually into mathematical thinking and problem solving through human-machine collaboration.
I have a short answer. I'm an engineer. Engineers solve problems. I tried to articulate the problem that I wanted to solve, and it's a great question. One that requires a bit more thought. But I think that's how I will approach using the tool. If there's a shortcoming in the class, I'll try to use this tool to address it. I don't know what'll come next. I think my colleague over here has a broader view, right? More expansive view.
You're very optimistic. I think that, I mean, I'm in the humanities, and we're the field that's really less interested in answers and more interested in generating questions. Yeah, that's I had a teacher when I was in grad school who said, in the humanities we ask the questions, let engineers and social scientists and everybody else grapple with the answers. That's of course a cheap, I shouldn't say that, but we're focusing more and more on the questions and less on solutions and answers. So I think we are not in a position where we as in language education, we as a field have like a great consensus about just like what are specific domains and when and all of that. I think we're still in the process of figuring it out, and it's super exciting, but it's also super frightening, because the moment we think we have an answer, we check Twitter and there's another tool out there that's completely, so the development of the technology is at the moment faster than the development of a thoughtful pedagogy, and that's the danger. Yeah?
I have a question for my colleague, but I don't want to end on a negative note, but I wonder, is it okay to be in time? So there's a recent article in The Atlantic, if you've read it, that is a bit of hand-wringing that our collegiate level students are not reading enough books. And you see there's a lot of discussion about this. I wanted to just say, from your perspective in the humanities, is AI going to exacerbate that? Is it a good thing? Is it a bad thing? Is there really an evolution? What are your thoughts on that?
I think we all don't read enough books. I don't read enough books. I don't read the amount of books that I read 20 years ago. I don't know if it has a lot to do with AI. I think it has really more to do with the information ecology, with all of these wonderful devices that we all have, and it's difficult, I think, to engage students into the, and it's not only the beauty but into this intellectual space of deep reading, yeah, of being in the novel. Yeah, I tell my students it's the ultimate virtual reality technology. Yeah, you can put yourself into other places, you can put yourselves in the shoes of other people, etc., etc. And we do that when we read, and when we read complex, long text, we can deal with complex ideas. But people don't read anymore, including myself. We spend much more time scrolling than reading. And the difference between scrolling and reading is what you need in order to be able to understand complex ideas, to engage in complex debates. Scrolling gives you the illusion of being informed, but you're just a consumer of information. And that makes you very deceptible. That builds the inability to deal with complex questions, and it makes you more attractive to simple ideas. And that's what we see in the society. Does it have to do with AI? I don't know. Does it have to do with a smartphone? Yes, I do. I tell my students it's the worst invention of the 21st century, but then I feel old, so I should shut up.
Well, thank you both again for being here. Thank you everyone for coming. We're just near time, so we'll say this is the end of the event. But just a quick heads up also, as I mentioned earlier, this is a part of a series, and so we do have another talk coming up next week on the 22nd with Dr. Lilac Malik from Wharton. So if you're interested in that, it's Practical AI for Educators, and the conversation can perhaps continue there. So thank you again.
Thank you. Thank you.